So we'll start our new chapter, which is the haloalkanes and haloarenes. This is the first lecture, and first topic which which we will try to cover will be the preparation of alkyl halides. See, beta, in preparation of alkyl halides, what we did earlier in earlier classes, we prepare alkyl halides from alkenes. From alkenes, we prepared alkyl halides. Second was from halogen exchange reactions. These two were done in previous classes. So again, I will try to repeat these reactions and more of all the preparation of alkyl halides we will try to do today, beta. So this is our agenda of our today's class. Let's say we have this table C. We have important families of organic compounds in which I have shown you different types of functional groups from alkane, alkene, alkynes, aromatic ring, haloalkanes, alcohols, ether, aldehydes, ketone, carboxylic acid, esters, amide, and nitriles. Beta, just write in the chat. Can you listen to me? Just write in the chat. Can you listen to me? Yes or no? Write just. ओके, चलो स्टार्ट करते हैं हम लोग. See, beta, preparation of alkyl halides. First reaction we will start. Preparation of alkyl halides. We all have done from alkanes. From alkanes, if I am preparing our alkyl halides, from alkanes, if I am preparing my alkyl halides, what we should see. So let's say we have taken first example. Let's say we have taken CH3, and what we do, we'll put what chlorine in HNO heat, and what will be prepared? What will be prepared? Let's say CH3, CH2, and Cl plus HCl will be removed. And this we have learned. If Cl2 is present in excess, if Cl2 is present in excess, see, all the hydrogen of this will be removed. So it will give us CCl3, this molecule. And second one we have seen, let's say we have CH4 and we do fluorination of this. So for fluorination in HNO, we all know fluorination is a very fast process in comparison to chlorination. So this reaction will be very fast. So you can't form CH3F. CH3F you can't form by this reaction, beta. So as you all know, for the reactivity of halogens, X2. So fluorine will be giving us very fast reaction, then fluorine, then bromine, then iodine, beta. This is about the reactivity of X2 group. Therefore, for fluorination, we have written, for fluorination, what you have to do? For fluorination, what you have to do? For fluorination, we will do first the chlorination in heat light. Beta, in heat light, always we remember that in heat light, always we have free radical mechanism. First, we will do the chlorination. In chlorination, you will form CCl3, all hydrogens of this will be removed. All hydrogens will be first removed. Will form CCl4, and then after you can form beta in fluorination. In fluorine excess, you can form CF4. Similarly, if you have CH3, ethane molecule, 2 carbons. You can do the chlorination in heat light. You form CCl3. Then you can again do the fluorination in excess to form us CF3 and CF3. So it's very important that for fluorination, you cannot do the fluorination direct. So direct fluorination you cannot do, but indirect fluorination you can do that. Similarly, we can see for iodination. iodination. See, in iodination, let's say we have CH4 plus iodine. And in the presence of heat light, if we do, we have to put in this reaction HNO3 or HiO3. So we will prepare CH3I and HI beta. See, beta, in this reaction, this HNO3 and HiO3 is a strong oxidizing agent. So it oxidizes the HI back reaction to CH3 and I2. And ये oxidize करता HI को H positive and I negative को to iodine back, है ना? So this HI will be the problematic. So इसको यहाँ से हटाने के लिए we put strong oxidizing agent because iodine is very slow process. This is a slow reactivity of iodination. So to increase the reactivity of this reaction, we add HNO3, nitric acid, and HiO3 periodic acid in this reaction. Similarly, see beta here. Next example, if I take, let's say we have this molecule. In this molecule, in this alkane, we do chlorination in UV light or heat light. We all know that in UV light or heat light, so it has to remove one hydrogen from any carbon. It has to remove one hydrogen and form CCl bond. So it can break this one, it can make this compound, or it can do what? It can make this compound. So two possibilities are here. It can make from this side, from first side, or from second side. But out of these two, first one will be the major product and other one will be the minor product. So we will see how this reaction goes. हम लोग इसको देखते हैं. So beta, this reaction goes by free radical mechanism. This reaction goes by free radical mechanism. And you all know free radicals are made in the help of helpers. Helpers are what? Helpers में H होता heat, E होता energy, L होता light, and PER होता peroxide. So whenever we have a helper on our arrow written, so you should know that it should be a free radical mechanism. है ना? अगर ये free radical mechanism है, so इसमें से if this hydrogen and out of this hydrogen is break by homolysis cleavage, अगर इन दोनों में से let's say this one and this one, so अगर A वाला टूटा, this bond भी break CH bond, अगर ये वाला टूटा तो रेडिकल यहाँ पर बनेगा. अगर B वाला let's say B1 hydrogen bond by free radical mechanism, so free radical will be formed this side. So out of A and B, if we see, first one is 2 degree free radical and the second one is 1 degree free radical. Out of 2 degree and 1 degree, we always remember 2 degree free radical is more stable. So we always remember, we always try to see in this reaction stability of free radicals. Stability of free radicals. So always 3 degree free radical will be more stable than 2 degree, then simple CH3 radical. Therefore, what happened? This 2 degree free radical will be made. And you will have to make this 2 degree free radical with chlorine, and this free radical will be made again, and this free radical and chlorine radical will together make us the major compound. Other will be the minor beta. Other one will be the minor, but this answer will be our major. So this chloride at 2 degree, will be major product. समझ आ रहा है आपको कि नहीं? है ना? So let's say we take second. This was our first thing, that this reaction we can do the chlorination, preparation of alkyl halides from chlorination, iodination. This example we have also did. So in the presence of heat light, we have seen that in the presence of heat light, it should be a free radical mechanism. Second example we will try to write. Let's say second preparation is from halogen exchange. halogen exchange reaction. What is halogen exchange reaction? We all have studied this halogen exchange reaction in our previous classes. Let's say first one is halogen exchange. First one हम देखते हैं. Let's say we have CH3Cl and we are doing this reaction in the presence of silver fluoride, Hg2F2, POF2, Hg2F2, POF2, TOF2 and SBF3. So what will happen कि यहाँ पर अगर यहाँ पर क्लोरीन और ब्रोमीन यूज किया अगर so this chlorine and bromine will be changed to in this presence of silver fluoride to fluorides, and next we will have the salt. Next we will have the salt. Let's see, we use AgF, so we will form AgCl salt or AgBr salt. So this salt we can get, this PPT we can get in this reaction. And because of this PPT only, the Le-Chatelier's principle tells us if in the product, if in the product PPT is formed, so reaction will go in forward direction. Reaction will go in forward direction. क्योंकि ये PPT form हो रही है and product is decreasing from the solution, because PPT is forming and product is decreasing from the solution. If product is decreasing from the solution, reaction goes in forward direction. We have learned PDF. We have learned the mnemonic PDF that if products are decreasing, reaction will go in the forward direction. So this is one of the halogen exchange reaction. इसको the special name of this reaction is what? Schwarz reaction. Schwarz reaction. ये हमने याद किया कि इस रिएक्शन को हम शॉर्ट्स रिएक्शन कहते हैं. हमें अगर हमारे पास लेट्स से वी हैव एल्काइल क्लोराइड और एल्काइल ब्रोमाइड इन द प्रेजेंस ऑफ दिस रिएजेंट, सिल्वर फ्लोराइड, मर्क्यूरिक फ्लोराइड, कोबाल्ट फ्लोराइड, एंटीमनी फ्लोराइड, वी गेट फ्लोराइड्स. वी गेट व्हाट? फ्लोराइड्स. So you can change the halogen from chlorine to fluorine using Schwarz reaction. है ना? Second one also reaction of halogen exchange reaction we have studied. Let's say we have any halogen, let's say X is what? Chlorine or bromine. We put in this reaction NaI and dry acetone. Dry acetone. है ना? Acetone आपको सबको पता, COCH3CH3. We dry it so that no moisture content should be in there. So अगर हमने NaI और ड्राई एसीटोन में अगर CH3X को रखा, हेलो एल्केन CH3Cl or CH3Br, but we will form CH3I and NaCl or NaBr. So again this is a PPT formation in this reaction. Again by Le-Chatelier's principle, it was told that if products are decreased in the reaction, PPT is formed, therefore products are decreasing from the reaction solution, from the dry acetone solution. If products are decreased, reaction will go in forward direction. So this reaction also, this is also one of the name reaction. इसको हम लोग प्यार से क्या कहते हैं? इसको हम लोग प्यार से कहते हैं फिनक्लेस्टीन रिएक्शन. फिनक्लेस्टीन रिएक्शन कहते हैं हम लोग इसको. This reaction is called Finkelstein reaction. Always remember, in Finkelstein reaction we use NaI in dry acetone. ठीक है? तो इसके बाद हम लोग करेंगे next reaction is our next reaction. We will start from, please write beta as soon as I am writing in the class. Listen to the things and write directly. If you are not writing beta, you will get these things. You will get the PPTs and all. But try to write and remember the things which I taught in the previous classes. So next we will start beta. Next third one we will start from alcohols. From alcohols, if I want to make alkyl halides, what should I do? So first thing I am writing from alcohols is reaction with halogen acid. Reaction with halogen acids. Halogen acids are what? Like HH, like HF, HCl, HBr, NHF. These are called halogens. They are acid, halogen acids. So what we will do, let's say we have an alcohol, ROH. R is any aliphatic group. कोई भी aliphatic group है. But a difference between we have aliphatic and aromatic. You all know, if we have a single carbon chain, double bond or triple bond, it is aliphatic. Or if we have aromaticity, then it is known as AR group. AR, है ना? उसको aromatic group बोलते. So let's say we have ROH and I put in this reaction, let's say HCl, concentrated HCl in anhydrous ZnCl2. ZnCl2 is a Lewis acid. Lewis acid है. So if I put concentrated HCl with anhydrous ZnCl2 in ROH, I will get what? I will get RCl plus H2. RCl plus H2. तो क्या करता? ये पॉजिटिव नेगेटिव अगर ROH में कंसंट्रेटेड HCl ZnCl2 के साथ डाला तो यहाँ पर H2O will go out and Cl will come. H2O will go out from here and Cl will come. So this is the best method to prepare. This is the best way to prepare from alcohol to alkyl halide. है ना? This is the method to prepare from alcohol to alkyl halide. Mechanism we will see beta. Mechanism we will see of this reaction. Let's say we have ROH. अगर इसके अंदर मैं HCl डालूंगा, so this ROH will act as a nucleophile. It will try to attack any electrophiles. है ना? So which electrophile it will attack? It will attack as the H positive. अगर यहाँ से इसने H positive पे अटैक किया, it will become RH2 positive. क्योंकि H positive भी आ गया O के ऊपर. So यहाँ पर and because of this OH which was earlier, which OH was converted to OH2. है ना? So this OH was bad leaving group beta. Bad leaving group. Bad. The OH was here, bad leaving group. It does not want to leave from here better. Whenever we put ROH into some acids, है ना? So this becomes a good leaving group and H2O, this bond will become weak bond because of H2O coming on. And this only is known as from bad leaving group, it become good leaving group, and it will leave R. So R को छोड़ के चला गया आपने दोनों इलेक्ट्रॉन्स इट हैज टेकन विद इट, तो R will become R positive. तो ये इसको क्या कहते हैं? कार्बोकैटायन. इसको कहते हैं कार्बोकैटायन. So once you put alcohols in HCl, directly आपको याद करना कि whenever you put acid on some organic compounds, on any organic compounds, you will always form carbocation बनता. And once carbocation is made, you all know, once carbocation is made, we have HCl, next was Cl minus left, so carbocation के ऊपर Cl minus attack करता, and lastly we form RCl with H2O we form. So this RCl is formed in two steps. First, we form carbocation. In the last, we attack the Cl minus on R positive to give us the RCl. है ना? And we always know whenever we have a carbocation, जब भी हमारे पास carbocation हो, it can do what? It can do ring expansion, it can do ring compression, or if there is no ring in the compound, it can go for rearrangement. It can go for rearrangement of the rings. And two rearrangement we have seen in our syllabus. We have two rearrangements. First one is 1,2 hydride shift. and second one is 1,2-methyl. So these two rearrangements are there in our syllabus. Just a So these two rearrangements are there in our syllabus. तो क्या करते हैं from alcohol if I'm making alkyl halides, I need to form carbocation and after carbocation I can make RCl plus H2. So देखें important points of this reaction are, let's see, we will write some important points of this reaction. First important point is, see beta, it goes through SN1 mechanism. It goes through SN1 mechanism in which carbocations are formed. In which carbocations are formed. After carbocation, it can go for rearrangement, ring expansion, ring compression, or rearrangement, RA. Second important point is in this reaction for the reactivity of alcohols. Which alcohol will be more reactive and which alcohol will be less reactive, we will see. So reactivity of alcohol is directly proportional to stability of carbocation. More stable will be the carbocation, more reactive will be the alcohol. So let's say I take 3 alcohols. अगर मैं यहाँ पर 3 alcohol लूँ, let's say this is 1 alcohol, this is second alcohol, and this is the third alcohol. है ना? So let's say we take here, यहाँ पर let's say we have taken here CH3, CH2, OH, and last is CH3OH. So out of these 4, which one will form carbocation more stable? So if H2O here, if I put H positive in all the compounds and I remove H2O from all of them, so it will make 3-degree carbocation, it will make 2-degree carbocation, it will make 1-degree carbocation, और यहाँ पर CH3 carbocation. So out of all these, we should remember that 3-degree will be reacting very fast, then 2-degree, then 1-degree, then CH3OH. So reactivity of alcohols will be 3-degree alcohol will react very fast, then 2-degree, then 1-degree. Always remember. Second point written. Third point, let's see reactivity of acid. Which acid we have used? Let's say we use HI, HBr, HCl, and HF. Out of all these 4 acids, you know that HI will be more reactive because HI is a strong acid. Because HI is a strong acid, you all know. Let's say HF, HCl, HBr, and HN. See beta, from going up to down, bond length is increasing, therefore bond energy is decreasing. So iska bond energy बहुत छोटा, therefore it is a strong acid. It is a strong acid because it can give H positive very easy, very easy. So out of all the halogen acid, HI will be the strong acid and the reactivity of HI will be the more. So this is the third point. Fourth point we will write beta. So let's say beta, if I have 1-degree or 2-degree alcohols, always remember we have to use concentrated HCl plus anhydrous ZnCl. But if I have 3-degree alcohols, you don't need to have concentrated HCl. You can do the reaction in simple HCl. You don't need to have concentrated HCl. And this anhydrous ZnCl2, which was a catalyst, you cannot use catalyst. This reaction you can do at room temperature also. And catalysts are required to favor the reaction. If you have 1-degree and 2-degree, you can favor the reaction and this reaction can go very fast. See beta, this concentrated HCl plus anhydrous ZnCl2 is called Lucas reagent. It is called a Lucas reagent. Whenever we have an alcohol and in the alcohol we put Lucas reagent, you should know that we are preparing from Lucas reagent any alkyl halide. Any alkyl halide we are preparing from the Lucas reagent. याद रखना है ना? And this Lucas reagent help us to this Lucas reagent, right बेटा? This Lucas reagent, make a hashtag here. Lucas reagent helps us to distinguish. It helps us to distinguish 1 degree, 2 degree, and 3 degree alcohols. So if I have given you 1 degree, 2 degree, 3 degree, the Lucas reagent can tell me how this, which one is 1 degree, which one is 2 degree, and which one is 3 degree. है ना? So let's say I have 3 degree alcohol, I have 2 degree alcohol, and 1 degree alcohol. है ना? अगर मेरे पास let's say यहाँ पर ये 3 degree alcohol है, ये वाला मेरे पास 2 degree alcohol है, और ये वाला मेरे पास 1 degree alcohol. So if I put here Lucas reagents in all, LR, Lucas reagent I write by LR. If I put Lucas reagent in all, suddenly जैसे ही मैंने इसमें 3 degree alcohol में put किया, 3 degree alcohol is very reactive, है ना? Because it is forming 3 degree carbocation. So you will see in the reaction turbidity, turbid हो जाएगा reaction जैसे ही immediately if I put Lucas reagent in this reaction. But in 2 degree alcohols, if I put the turbidity, you can see the turbidity after 5 to 7 minutes. And इस वाले में turbidity is not seen instantly. Let's say we have 1 degree, turbidity is not seen, or you have to see turbidity on heating. You have to do the heating for 1 degree alcohol to see the turbidity. है ना? So if I have to distinguish between 3 degree, 2 degree, and 1 degree alcohols, what I need to do, I put in all the 3 Lucas reagent. और जिसमें सबसे पहले turbidity आ गया वो 3 degree वाला, जिसमें थोड़ी देर बाद turbidity आया तो वो 2 degree वाला, और जिसमें बहुत लेट पार्ट आया मतलब आया ही नहीं, so you have to heat, मतलब turbidity नहीं आया, again you have to heat to see the turbidity, तो मतलब वो 1 degree वाला alcohol. So this Lucas reagent is also known as Lucas test. This is the Lucas test for 1 degree, 2 degree, and 3 degree alcohols. This always remember beta. ये याद रखना आप अच्छे से Lucas test करने के लिए. Second one we will write, see. Second one, देखें, from alcohol if I want to convert, from alcohols, if I want to convert to alkyl halides, from alcohol to alkyl halides, from alcohols to alkyl halides, first method was you can use Lucas reagent in this reaction. First method was you can use Lucas reagent. You can use Lucas reagent. Second method, other methods I am telling you, let's say I have an alcohol, I want to convert this alcohol to alkyl halide. So let's say I have first reaction with PCl5 and a phosphorus pentachloride. अगर इसके साथ reaction करते, I will form RCl plus POCl3 plus HCl, and this is an SN2 reaction, है ना? Other one I can do, I can have PCl3, phosphorus trichloride. Here also I can have RCl H3PO3, है ना? Third one I can do beta, if I have NaBr or KBr. If I have NaBr or KBr in concentrated H2SO4, so I can form here RBr. I can form bromine from OH in the presence of NaBr and KBr in concentrated HNO4. और इसके साथ NaHSO4 plus H2. Next one, if I have this similar reaction, if I have PbR3 in diethyl ether. Diethyl ether is a solvent here. If I use this solvent, so here also RBr is formed beta. Alkyl bromides. For chlorides, you can use PCl5, PCl3, For bromides, you can use NaBr, KBr in concentrated H2SO4 or PBr3 in diethyl ether as solvent. है ना? So let's say also last one also. Let's say we have red phosphorus. Phosphorus has many allotropes. उसमें से red phosphorus, black phosphorus also we have. So let's say we have red phosphorus. In red phosphorus, I do iodine. So यहाँ पर red phosphorus और iodine के साथ iodine का alkyl iodide is formed. है ना? So here you can write beta in place of X2, you can write X as I2, Br2, है ना? I2, Br2, or you can write here chlorine also. So here according to that, X will be formed. I will correct it. According to that, Rx will be formed. अगर कोई X के साथ हम लोग रिएक्ट करा रहे हैं, X2 is a halogen. तो अगर I2 होता तो अल्काइल आयोडाइड बनता, Br2 होता तो अल्काइल ब्रोमाइड बनता, अगर Cl2 होता तो अल्काइल क्लोराइड बनता, है ना? So out of these 4-5 reactions, these 4 reactions, this chlorides, this is for chlorides, this is for bromides, this is for chlorine, bromine, iodine, anything. So you can use red phosphorus with X2. Very important reaction, this also beta. Last one I am telling you, let's say I have ROH and I am putting in this reaction SOCl2 beta. This reaction is very star reaction. You can write SOCl2 is also known as thionyl chloride. Thionyl chloride. If I put thionyl chloride in ROH, I will get RCl plus H2O plus SO2. So this one, from making alcohols to alkyl halides, this reaction is the best reaction. Best reaction, why? Because we are getting H2O and SO2 as gas. So these two will be removed and the last product we can get directly by simply directly इसको reaction जैसे ही कराते, तो जैसे ही reactant को कराते, you put SOCl2, directly you will get your products and the side product will be removed. Side product will be removed as gases. अगर side product remove ही हो गए, you get your product as pure product मिल गया आपको. So this is the best reaction which you can do for converting the alcohols to alkyl halides. And इसको हम लोग, the mechanism of this reaction is, here only write beta, the mechanism of, here only write, the mechanism of this reaction is SNI reaction. इसको कहते हैं nucleophilic substitution inversion. Nucleophilic substitution inversion. And इसका we will see the mechanism in our later classes. अब यहाँ पर यही हम लोग देखते हैं. Second example, if I take, let's say I take same SOCl2 in the presence of pyridine. In the presence of pyridine, I am doing this reaction ROH to alkyl halide. अगर यहाँ पर करते तो same product will be formed like above. Same product will be formed RCl, H2O and SO2. Same product will be formed. But this mechanism will go through, ये वाला कौन सा mechanism होता? This will go through SN2 mechanism. This will go through SN2. We will learn about SN1, SN2 and SNI reaction in our nucleophilic substitution class, which will be our next class. We will learn about this mechanism in our later classes. But अभी हम लोग यहाँ पर prepare कर रहे हैं. So we are preparing our alkyl halides. And this reaction is known as Darson reaction. Darson reaction. So you have to learn the reaction name, their reactants, their products, and their reagents which you have used. Let's say Lucas reagent, we use concentrated HCl plus ZnCl2. And in this Darson reaction, we will use SOCl2 in pyridine. तो ये याद करना आपको, ये आपको याद करना है अच्छे से, है ना? So these were all. So हमने यहाँ पर, let's say we see the summary. In this summary, we will see how we had made alcohols to alkyl halides. So first method was you can use Lucas reagent. You can use Lucas reagent, which was concentrated HCl plus ZnCl2. Second method was you can use PCl5. Third method was you can use PCl3. Fourth, if you want to prepare bromides, you can use NaBr or KBr in concentrated H2SO4. है ना? Fifth method was you can use PBr3 plus diethyl ether है ना? To make here bromides RBr if you want to make, and all these three you can make RCl है ना? Similarly, if you want to make here chlorides, you can use SOCl2 or you can use SOCl2 plus pyridine. Just the difference here, you will get RCl. Difference here is in this you will get it will go through SNI mechanism, and this pyridine one will go through SN2 mechanism. So this is the summary of if you want to convert alcohols to alkyl halides, है ना? अगर आपको alcohol से alkyl halide करना है तो ये वाले reagents you can use on the arrow. If somewhere you find these, you should know कि आपको alcohol से alkyl halide change कर रहे हैं, है ना? From one functional group to another functional group. This OH and Cl are called what? Functional groups, है ना? So this is our main thing. अगर अब next thing we will see now. So this is our main thing beta हमने देखे. Again I am revising preparation of alkyl halides. Let's say from alkane I prepared by free radical mechanism. Second thing was from halogen exchange. First reaction was Schwarz reaction, in which I use silver fluoride. Second reaction was Finkelstein reaction, in which we use sodium triacetone. Fifth one, we start preparing our alkyl halides from alcohols. With alcohols, we can do with Lucas reagent. The mechanism was given, carbocation was made as the intermediate, SN mechanism it was. And then we have Lucas test. है ना? We prefer Lucas test to distinguish between 1 degree, 2 degree, and 3 degree alcohols. है ना? After this Lucas test, we came out to make alkyl halides from PCl5, PCl3, NaBr, PBr3, red phosphorus, and X2, red phosphorus also from X2. Then SOCl2 thionyl chloride. Then we have thionyl chloride plus pyridine as a solvent. अगर pyridine के साथ करते तो कैसे होता? So this was all about from alcohols. Third one we will see beta. This is the third one. Fourth one we will see how to make alcohols. Now we will see preparation from alkenes. If I want to prepare my alkyl halides from alkenes, तो देखते अगर हमारे पास CH3CH CH2 है, and if I put in this alkene, क्या put करते हैं इसमें? Let's say HCl, है ना? HCl is what? Acid. And I have always told whenever you put HCl into any organic compound, you always make carbocations. You can make here the carbocations. तो देखें, let's say we have alkenes. Alkenes are nucleophilic in nature. They will attack which one out of HCl and Cl? So alkenes are electron rich. They will attack the H positive. तो अगर यहाँ पर H positive पे attack हुआ, so H can come here, carbocation can be made here, है ना? And second possibility is H can come here and carbocation is made here. So out of these two, first one will be the more stable carbocation because it is 2 degree, and second one is the 1 degree carbocation. So आपको यहाँ पर देखना कि क्या product आता. So again you have Cl minus, so Cl minus can come here or here. So if it is forming 2 degree carbocation, Cl will come here and CH3 will become this one. And if it is coming at 1 degree, so यहाँ पर Cl है ना? So out of these two, products, you should know which product will be found major, which will be the major product. इन दोनों में से कौन सा major product है? So let's see this out of these two, this इसमें से कौन सा बनता, इनमें से कौन सा result बनता? This is given by Markonikov rule. This is given by Markonikov rule, है ना? And these reactions are known as, देखें, we will see Markonikov rule, है ना? So हमें कैसे पता लगेगा? How we will get to know that Cl will come this side or this carbon? कौन से carbon पे आएगा? So by Markonikov rule you can tell. Let's say I have ये वाला. Let's say I have this alkene and I put, let's say, X and Y, है ना? So out of these two, let's say electronegativity of Y is greater than X. Out of these two, electronegativity of Y is less. See बेटा, अगर electronegativity Y का ज्यादा है, so Y will be del negative and X will be del positive, है ना? So because Y has electronegativity more, so always remember Y will try to come this side, and Y will try to come this side. More electronegativity will come and try to come on the carbon which is more substituted. So देखें यहाँ पर Markonikov told that more electronegative atom will attach where the more electronegative atom will attach at more substituted side. So अगर यहाँ पर Y more electronegative atom है, so it will attack at more substituted side. More substituted side का मतलब क्या होता? This carbon is having this carbon and this carbon. तो इसके पास तो more substitution he has, है ना? Substitution more है इसके पास, and this carbon is less substituted. तो let's say we take an example, अगर ये वाला है and I put in this HCl, so Cl minus, which is more electronegative than HCl, will come at two position. It can come at more substituted side or at less substituted side. So out of these two, Cl minus will always try to go at more substituted side. So Cl minus यहाँ आता और HCl will come at less substituted. Always remember beta. So दूसरा वाला product will be the minor product. This will be the our major product, है ना? तो फिर से देखें, Markonikov rule will tell us that from alkene I am converting to, if I am converting to, I am removing the alkene, I am making any XY, using any XY. So how to convert from alkene to any other substitute? One more example देखें अगर, let's say I have one more example. Let's say these examples I have. देखें, let's say we have unsymmetrical alkenes. What are these unsymmetrical alkenes? जिस alkene के substituents are different. The alkene substituent should be different. See here, there are two hydrogen, there is one CH3 and one hydrogen. So this is what? Unsymmetrical alkene. अगर यहाँ पर पूरा full symmetry is made, this is known as symmetrical alkene. So you can't tell here which is the more substituted side, which is the less substituted side, है ना? अगर आपके पास unsymmetrical alkene है, तभी आप उसमें बता सकते कि आपको H पॉजिटिव और Br माइनस में से कौन सा कहाँ पे आएगा. तो let's say we have this. So we always know that more electronegative Br minus will come at more substituted site. यहाँ पर नहीं आता, यहाँ पर तो बहुत ज्यादा substitution है. He has more substitution. This carbon has more substitution with respect to this. So this product में यहाँ पर Br आएगा और यहाँ पर H आएगा, है ना? Let's say second example also, if I take, let's say here H positive Cl minus and we have an alkene, है ना? So Cl minus can come here or here by Markonikov rule. So this one will be the more substituted side. ये हमारा more substituted side है और Cl will come here and H will come here. This double bond will be broken. This double bond will be broken and Cl will come here and H will come here. अगर दूसरा वाला कब बनाते, if I make this H and Cl, this is wrong, beta. This is wrong. Why? Because it is breaking our Markonikov rule. This will be the minor product. This will be our major product. है ना? Simple. This one also, see, we have two sides of alkene, H and Br. Br minus, which is more electronegative, will come which side? Which side it will come? देखें. So it will try to come Br here and H here. तो कुछ नहीं करना, nothing more difficult it is. डबल बॉन्ड को ब्रेक करना है और H और Br को अटैच करना है. H और Br को अटैच करना है. लास्ट वन D also, let's say I will do for you. अगर डबल बॉन्ड को ब्रेक करते तो आयोडीन माइनस विच इज मोर इलेक्ट्रोनेगेटिव will come this one or this one carbon. It can come this carbon or this carbon, but this carbon is more substituted side. ज्यादा सब्स्टिट्यूशन है, तो अगर ज्यादा सब्स्टिट्यूशन है तो यहाँ पर ही आयोडीन आएगा. This is our product. Even also you can do. Here, see beta, even is a beautiful example. We will do by mechanism. See beta, in these two sides, both are same. On which side Cl will come here? It can come here or it can come here. So which is our product? We will try to see by mechanism. तो mechanism देखते. mechanism देखने के लिए हमें क्या करना? Mechanism of this reaction will tell what we have to do. Let's say we have this compound. And in this compound, if I put HCl, है ना, तो ये alkene which is nucleophilic in nature, will attack on H positive, है ना. So if it has two possibility, it can take this and it can make positive. अगर alkene को तोड़ना यहाँ पर नेगेटिव आना या पॉजिटिव आना, और नेगेटिव अगर H पॉजिटिव को लेता तो H पॉजिटिव ये बनता. और सेकंड केस अगर यहाँ पर नेगेटिव आया, यहाँ पे पॉजिटिव आया, तो सेकंड केस विल बी दिस केस. In this, carbocation is made here and H came. See, two cases of carbocation we have made. Always remember, whenever we put acid in any organic molecule, we will form carbocation. But which carbocation to form? We should know by hyperconjugating structure. अब इसका अल्फा हाइड्रोजन कितना? इसका अल्फा हाइड्रोजन 2 hydrogens from here. Let's say I draw by blue. 2 hydrogens this one, 2 hydrogens these one. How many alpha hydrogens? 4 alpha hydrogen. Here alpha hydrogen count. We have 1 alpha hydrogen. We have second alpha hydrogen. Here we have 3 alpha hydrogen. है ना? तो ऊपर वाले में तो 4 हैं, इसमें 3 हैं, है ना. So कौन सा प्रेफर होता? Where we have more alpha hydrogen. So this one will be more stable than first one. और अगर ये वाला है तो इसमें से अगर कार्बोकैटायन यहाँ पर बनेगा, H यहाँ आएगा, then again Cl minus will come and attack on this carbocation to make the bond of CCl. है ना. So out of these two, the answer should be this. Answer should be others. है ना? So by mechanism you can tell the product of the reaction. So mechanisms are beta very important for our reactions. So ये तो हमारा मार्कोनिकॉफ रूल हुआ, है ना? नेक्स्ट वन इज आर एंटी मार्कोनिकॉफ रूल. आपको भी पता है. लेट्स से आई टेक एन एग्जांपल. लेट्स से वी विल प्ले वन क्वेश्चन. One question will play. Let's see who can solve. I have in this I and Cl interhalogen compound, iodine and Cl, है ना? तो अगर iodine और Cl अगर टूटता तो यहाँ पर Cl can come here or iodine can come here. First possibility. And second possibility is that Cl come here and iodine come. So out of these two, this, let's say this is our A answer, this is our B answer, है ना? And you have to use Markonikov rule. You have to use Markonikov rule. You have to tell out of these two, which one is more electronegative, will come to more substituted alkene, will come to more substituted side. So out of these two, which one is correct? Out of A and B, which is the answer? Whenever I put alkene with ICl, iodine chloride, ICl, interhalogen compounds, है ना? You can write in the chat box out of A and B answer. Answer tell A or B. You can write in the chat box. Start solve करें इसको. Simple it is. Chat box में लिखें. अब हटो वीडियो चलाए. चला दे. So see beta. Out of A and B, we will check our answer, which is our correct answer. See beta, if we have iodine and chloride, we all have remembered from chlorine, bromine, iodine, down the group as size increases, electronegativity will decrease. So out of chlorine and iodine, which will have more electronegativity. So अगर नीचे जा रहे हैं तो electronegativity decrease हो रहा, तो Cl minus की electronegativity more than iodine, है ना? तो Cl minus की electronegativity, if it is more, if Cl minus is more electronegative than iodine minus, तो Cl minus will come at more substituted side. Cl minus will come at more substituted side. If Cl minus will come at more substituted side, तो Cl minus यहाँ से Cl minus will go and attack the more substituted side, and answer will be our B. Our answer will be B. देखे सभी, जिसने अपना आंसर A लिखा है, they can check their answer, that answer is B. अच्छा, ABCD बता. But I will take your questions after the class, don't worry. Yes, beta. Aparna, yes, beta. ICl will dissociate as I positive and Cl minus because Cl minus is more electronegative than. What factors affect the stability of alkylides during their separation? Beta, we will try to see where we have to use which factors, in which reaction we have to use factors. Beta, Ullas, you can go out from the class. हाँ बेटा, टर्बिडिटी वी हैव सीन बेटा, जैसे ही हम उसमें डालते हैं यू कैन सी प्रेसिपिटेट्स फॉर्मिंग, है ना, दैट इज कॉल्ड टर्बिडिटी। अगर प्रेसिपिटेट उसमें फॉर्म हो रहे हैं उसको टर्बिडिटी कहते हैं। वी विल सी फर्दर अगर आगे आएगा उसमें विकास रिएजेंट में टर्बिडिटी, जैसे वाइट प्रेसिपिटेट्स विल स्टार्ट, नॉट प्रेसिपिटेट्स और लेट्स से वाइट वाइट सब्सटेंसेस, अगर उसके अंदर अगर कंपाउंड चेंज होगा एंड वाटर इज रिमूव्ड तो वो टर्बिड हो जाएगा। विल सी, उसको देखते हैं। So now you came to know कि इन दोनों में से आउट ऑफ ए एंड बी विच इज द राइट आंसर, है ना। सिंपल इट इज, वेरी सिंपल इट इज। यू शुड नो कि अगर इसमें से इलेक्ट्रोनेगेटिव कौन सा, विच वन इज मोर इलेक्ट्रोनेगेटिव एंड विच वन इज लेस इलेक्ट्रोनेगेटिव। चल नेक्स्ट वन सी बेटा, लेट्स वी हैव एंटी मार्कोनिकॉफ रूल। मार्कोनिकॉफ रूल, what is anti Markonikov rule? Let's say we have CH3 CH double bond CH2 and I put in this reaction HBr with one peroxide. If I put peroxide in the reaction, let's say H2O2 or benzoyl peroxide, if I put benzoyl peroxide in this reaction, so what will happen? This H positive and Br negative नहीं बनता इसके अंदर। if I use peroxide, just a minute beta, just a minute beta. You are disturbed. So here only we'll start. Let's say we have peroxide in this reaction. So we will see anti-Markonikov rule or more substituted side. यहाँ पर Br will come here and H will come. This is the opposite of Markonikov rule, है ना। ये तो opposite है Markonikov में। इसमें क्या होता, more substituted, more electronegative, more electronegative, more electronegative part will come at less substituted side. more electronegative part will come at less substituted site. और इसको हम लोग लिखते, so the mechanism of this reaction you can write बेटा, mechanism आपको पता है, this should be, if there is peroxide in the reaction, the mechanism should be the free radical mechanism. Free radical mechanism. You all know, if on arrow it is written helper, so it should be the free radical mechanism. और free radical mechanism में हम देखते हैं कि always in free radical mechanism there are three parts of free radical. Always first part is the initiation part, second part is the propagation part, and third part is the termination part. Termination part. So first part अगर हम start करते of this reaction only, देखें first part, if I start of this reaction, first part देखें of this reaction will be initiation. Initiation, how to initiate this reaction? क्या हुआ हमारे पास, अगर हमारे पास ये डबल बॉन्ड है और हमारे पास HBr है और हमारे पास एक पर ऑक्साइड बॉन्ड है, OO बॉन्ड इज नोन एज पर ऑक्साइड बॉन्ड है, तो हम लोग इसको कैसे इनिशिएट करते? सो ऑलवेज रिमेंबर व्हेनेवर वी हैव peroxide bond, this non-polar peroxide bond will break and form free radicals. ये फ्री रेडिकल बनाया इसने अपना peroxide का. Again this free radical will attack on this HBr to give us free radical of H and free radical of Br, and this ROH will be formed and Br radical will be. अगर Br radical यहाँ पर, so here first step will be the formation of Br radical. Formation of Br radical, है ना? तो पहले इसने अपने peroxide, this bond is known as peroxide bond, this bond was broken by peroxy linkage और यहाँ पर free radical was formed, and this HBr bond was broken by this this peroxide to give us Br radical as a formation. So second one देखते, second one में देखें, let's say we see the, let's say this was our initiation, second one see propagation. Propagation का मतलब आगे कैसे बढ़ता है, how it is moving forward, है ना, how it is moving forward. So अगर हमारे पास ये वाला एल्कीन था, this alkene we had and this Br radical we had, so this Br radical will attack here to give, this Br radical will attack and this alkene will again go for homolytic cleavage. Homolytic cleavage होता है इसका, और यहाँ पर अगर homolytic cleavage होता तो यहाँ पर this Br, this radical and this radical will be made, and Br radical can make bond with this first one or with second one. अगर ये पहले वाले के साथ बनाता तो यहाँ पर ये वाला रेडिकल बनेगा CH2 and Br will come here. अगर ये सेकंड वाले के साथ बनाएगा तो यहाँ पर ये वाला बनेगा. So out of these two, you all know second one is more stable. 2-degree radicals are more stable than 1-degree radicals, है ना? So this one will be made and this one will not be, है ना? ये नहीं बनेगा. So this, after this only, this radical will go to another Br. This radical will go to another Br to give what? To give CH3, CH2, CH2 Br here. Now see this hydrogen attached came to this carbon, ये वाले कार्बन पे आ गया, and Br came here. Br came here beta. Br didn't came here, Br came at the side, less substituted carbon, because of stability of free radical. Because of stability of free radical. Because of stability of free radical it came here. तो अगर ये यहाँ पर आया, so again Br radical was formed from here. And this Br radical will again go back. This Br radical will again go back and will again attack the new molecule of CH3 double bond. So and this way this reaction will go in a chain. ये चेन में चलता जा रहा है, ये चेन में चलता जा रहा है, ये बनेगा, फिर यहाँ से पहले Br रेडिकल बनेगा, फिर वहां से फिर इसके ऊपर अटैक होगा, ये 2 डिग्री एल्काइल फ्री रेडिकल बनेगा, यहाँ से फिर HBr पे अटैक होगा, फिर यहाँ पर H यहाँ आ गया, Br यहाँ आ गया, फिर Br माइनस, फिर अगेन. So this is known as propagation of the reaction, moving forward of the reaction. And third part is the termination of the reaction. मतलब कहाँ, where the reaction will stop, where will the reaction will stop. So अगर stop कैसे होता, let's say we have Br radical and another Br radical. So Br radical was the only person who was going forward and forward, है ना. अगर ये दोनों साथ में आके they together come and they make Br2. So once Br radical is removed from the reaction will go for termination, है ना. तो अगर वहां पर निकालना है तो आपको टर्मिनेट करना है, तो Br रेडिकल वहां पर अपने Br रेडिकल के साथ करता कंबाइन टू मेक Br2 and the reaction is terminated, है ना. So this reaction will tell us about the mechanism of this process, mechanism of anti-Markonikov's rule beta. So always remember, in anti-Markonikov's rule we have free radical mechanism, and more substituted, more electronegative part will come at less substituted site, है ना. ये देखें, हमेशा से देखें यही होता. Let's say I take an example, this, and I put in this HBr plus H2O2. So here can be two answers, this one, or here can be this answer, H can come here and Br can. So let's say this is A, this is B. Done. So इनमें से first product is Markonikov's product, Markonikov. But whenever we have H2O2, whenever we have peroxide, more substituted will come at less substituted side. More electronegative will come at less substituted side. So B will be our answer and A is not the answer, because B is anti-Markonikov's rule. B is anti-Markonikov's rule, है ना. क्योंकि B anti-Markonikov है and we have used peroxide in this reaction, so हमारे पास B will be our product and A will not be our product. One more example I will give you. एक और example देखते हैं. Let's say we have this cell and I have HBr plus H2O2. So you have to tell the product H and Br can come here, or if I remove the double bond, Br can come here and H can come. Out of A and B, write in the chat box which is the correct answer. I will open the chat box to you. Write in the chat box which is the correct answer. किसी ने लिखा है, can you sir please teach little slow down sir? Slowly. Don't worry beta, you all will get these lectures. I'm just preparing my lecture, you just see. कोई बात नहीं बेटा. A little fast I'm going, I know, but this all was done in your previous classes, है ना. थोड़ा सा आपको तेज चलना है. Tell the answer. Should I repeat the question? See, question is, let's say we have this alkene and I have to convert, wait. Let's say I have this alkene. I have to convert from this alkene to alkyl halide. Done. If I have to convert, it is given HBr and H2O2. If HBr in H2O2 it is given, you should know कि इसको यहाँ पर एडिशन करना, इन दोनों को ऐड करना, if I have to add H positive and Br minus on this, अगर इस पे ऐड करना, so H2O2 is given, you should know it is free radical mechanism, and it is anti-Markonikov rule beta. It is anti-Markonikov rule. अगर anti-Markonikov rule है, अगर एंटी मार्कोनिकॉफ रूल है तो हमें एल्कीन को अगर यहाँ पर अटैच करना, सो बी आर माइनस आर मोर इलेक्ट्रोनेगेटिव पार्ट will go in anti Markonikov rule towards less substituted side. Br minus will go towards less substituted side. So this substituted side, out of these two substituted side, this substituted side is more substituted, and this is less substituted side. So out of these two, Br minus will come and attach here. So out of these two, A will be our correct answer, B will be our wrong. Understanding or not? फिर से देखते, A will be our correct answer because Br minus will come at this position, less substituted side, and will attach here, and H will come and attach here. फिर से देखते, let's say one more example I take. एक और एग्जाम्पल लेता हूँ, आपके मॉड्यूल में भी दिया है, one beautiful example is given in your module. Let's say this. देखिए, let's say we have this alkene on the, यहाँ पर we put HBr plus H2O2. Done. And another we have simple HBr. If we have H2O2 के साथ है, तो आपको तो ये पता है, ये तो पेरोक्साइड है. अगर ये पेरोक्साइड है तो यहाँ पर एंटी मार्कोनिकॉफ होगा. अगर पेरोक्साइड नहीं है, सिंपल HBr है, तो यहाँ पर तो मार्कोनिकॉफ होगा. We have to use Markonikov rule to add HBr on alkene, है ना? So you know this site of carbon is less substituted site, and this site of our carbon is more substituted site. So out of H and Br is more electronegative, and if I have anti-Markonikov rule, so Br will come where this side or this side, it should come beta less substituted side, है ना? तो इसको less substituted side पे आना in anti-Markonikov by free radical mechanism, और अगर हमारे पास सिंपल HBr है तो हमको क्या करना, Br minus will come where? Br minus will come at more substituted side. देखें, सिंपल इट इज. बताएं बच्चे, सिंपल इट इज. One more example we will take. Let's see. One more example if I take. Let's say summary में, if I tell you the summary of our reactions today. आज summary देखते हैं. I won't teach you much beta. Don't worry. It's simple beta. It's very simple. Let's say we have this one. If I put in this HBr, simple. If I put in this reaction HBr, H and Br, where they will come, है ना? So Br minus is, let's say this is HBr simple, so this is Markonikov rule. Markonikov rules tell more electronegative will come at more substituted side. More वाला more पे, more वाला मोर के ऊपर. So this out of these two sides, if I have this side and this side, this one is the more substituted side. Substitution ज्यादा है ना, इसके पास ये भी है, ये भी है, इसके पास तो सिर्फ ये है. दिस कार्बन के पास तो ये वाला substitution है. So this is less substituted side. So Br minus is more electronegative, will come at more substituted side. तो Br minus कहाँ आया? यहाँ पर आया. और H कहाँ आया? H यहाँ पर आया, है ना? So this will is our Markonikov product, है ना? Second one, if I take HBr plus H2O2, if I take by mistake, peroxide if I take with HBr. Now you know this is anti-Markonikov rule. This is anti-Markonikov rule, and this should go. This HBr should come. This Br will come. This Br is more electronegative, will come at less substituted side. तो मार्कोनिकॉफ में बेटा और एंटी मार्कोनिकॉफ में ये Br माइनस कहां पर आता? लेस सब्स्टिट्यूटेड साइड, मतलब Br माइनस विल कम हियर एंड H विल कम, and opposite of this. So always remember, by summary I am telling you again, last time I am telling you, यहाँ देखें, let's say, always remember, let's say we have Markonikov's rule. Always remember, Markonikov rule tell more electronegative atom will come at more substituted site, and anti-Markonikov rule tell that more electronegative atom will come at less substituted. See, बस इतना याद रखना है आपको. टुडे यू हैव टू रिमेम्बर दिस मच ओनली, कि आपको मार्कोनिकॉफ और एंटी मार्कोनिकॉफ करना आ जाए, है ना? द मोटिव ऑफ टुडेज क्लास वाज दैट यू शुड नो विच वन इज द मार्कोनिकॉफ एंड विच वन इज द एंटी मार्कोनिकॉफ. क्या भेजने लगे यार? इंस्टाग्राम रील हेयर ओनली शिवा साई, सब हटाना पड़ेगा. आई नीड टू रिमूव. वेट वेट बेटा, डोंट वरी बेटा, एक एक को चुन चुन के निकालूंगा क्लास से. थोड़ा बहुत अगर प्रॉब्लम कर रहे हो, यू शुड बी सेंट होम. Who is this?